All right, there we go. So now I think we're recording. I think this is the bell word here. Oh, my board is so messed up. Fun Shirt Thursday is 90s. That goes along with the school Spirit Week thing. So all right, here we go. So really quickly, I'm going to do this off and on. For those of you that are going to do that retake on Monday, there was some mistakes that have been made throughout these circle quizzes that I'm just kind of trying to correct individually. Doesn't replace any tutoring. You still have to do tutoring. Oh, man. Here, we'll just do it. Oh, all right, that's even better. So when we have a circle, a lot of people, like way too many people, did what I'm about to show you on the quiz. They saw some kind of a number in here, 9 degrees. And they said, oh, well, that arc is twice that 9 degrees. That's not correct. The only time it's twice is when it is an inscribed angle, or there's that whole situation where it's a tangent and a secant. But the key is the vertex is on the circle. That's when it's twice. If it's not, if the lines crossing the vertex of the angles, if they're not on the circle, then it's not multiply by 2 or divide by 2. You have a formula you have to use. And that wouldn't make sense anyway, because if this is 9, what is this little tiny angle down there? 9, they're the same, right? How could I multiply this 9 and get that, and then multiply by the same number and get an arc that is totally different shape? Like that wouldn't even make sense. I can't multiply and get 2 different numbers starting with the same number. So again, a lot of you did that. And I don't mean a lot of you in this class necessarily. I just mean a lot of students got that situation confused with this situation, just multiplied the angle by 2 or divided the arc by 2, whichever way you're going. So again, inscribed angle, half the arc. So that will be 30 down there. This is the one where you had to do the formula. You had to take the 2 arcs, add them together, and then divide by 2. That was, we said, when 2 lines cross inside the circle. That's how we did it. That was the one sheet we worked on last week, that 1-page sheet. Anything else from that? I think that's it. All right, so now, that's not the word, so I'm corrected in 3. Okay, so we got to wrap up circles. Here, I'm going to try to do this really quickly for the 4th time today. So turn to your last circles chapter if you want. I'm going to wrap it up in like 5 minutes because it is very complex stuff. I just want you to at least recognize this concept when you see it. So we have circles. We've been working with them forever. What do we say circle is? What is a circle? Weak field. Oh, people thought alien created it, and I said no. This is all that really happened. So we go like that, but what are we doing? Set of all points left. There's a little more to it than that.
All points are equal distance
Yeah.
from the vertex.
So it is a set of points, so it's not one solid thing. It's a set of all points that are the same distance away from a central point. So every point on that circle is the same distance from that center green point. That's what the radius is. We said the radius, no matter where we're at on a circle, that's the radius. And it's the same length as that radius over there. And this one would be the same length, and this one would be the same length. Every radius is the same length because every point on the circle is the same distance from the center. That's what a circle is. Set of points that is the same distance. All of them are the exact same distance from that center point. So if they're always the exact same distance, they follow a pattern then there's an equation that we can create for any circle. That's what this is. This is the most basic version of it. It's just you take the x's and square it, take the y's and square them, and then you say equals the radius squared, which looks like what formula we've done. That was right there. That's just a squared b squared equals c squared. So if we had a triangle drawn in from the circle, so there's a point on the circle. So if we drew in the radius, so you see where the radius is, it's within your pages too. If I said, okay, well, what would my x and my y value be for that point? Well, I would just go from this center of the circle out to the x value out here. So whatever that number is right there is my x length. It's how long that side is. Well, this would just be from this point here up there. Boy, how do I forgotten how to draw these little bracket things? So that's just how long is that length? How long is it from here to here on the y-axis? That's what this is, the length. Again, y is the length, x is the length. I'm getting it though by using the x values and the y values. If this is 0, here I'll put numbers in. So let's say this point right here is probably the same number, but I'm going to make them different. Actually, it would have to be the same number too. So if we know that point on the circle, that green point is 5, 5, that means this value right here is 5. I mean, that's how I get that value. That's got to be 5. Well, that means this y value, oh, it's in the wrong spot. It's fine. That means that y value has to be 5. So the length going from 0 to 5 is just 5. That's how long that is. Going from 0 to 5 is just 5. How long that is. All we're doing, what did we say length is? It is, but like, what is it really mathematically? Oh, all right, thank you. Mathematically, what do we say length is? Oh, boy, my board is super tight. Let's assume that's a straight line. How long is that line? Get that. Get that. What's the math you're doing? Nope. Counting is length. How'd you get that? How would you get 7 from 10 to 3? It's subtraction. We said that before. Length is just subtraction. I take where I started, subtracted from where I got to. So that's all length is. Now here, we just happen to be subtracting 0 from 5, so it's just that same number. Same thing here, we're subtracting 0 from 5, so it's just that same number. But that's not always going to happen. Sometimes the circle may not have a center that's at 0, 0. Sometimes the circle may be somewhere else on the graph, anywhere else on the graph. And we can't just say that the length is going to be the same exact number as what the x value is. Not right now. I don't even know if you're going to make it. So if that circle changes, now if it is at the center, then this is the equation of a circle. We're just basically figuring out what is the value of the hypotenuse pretty much. We're doing a squared plus b squared is c squared. So we're just solving for whichever piece we need to solve for. If that circle is not at the center, so again, here's 0, 0 down here. Our circle does not have a center at 0, 0. It's got a center way over there. This just represents the x and the y that is the center of that circle. So it's not 0, 0 anymore. So in order to figure out, so I'm going to plug some numbers in. Let's say this point was, now we can do different values. So the center of that circle is 5, 6. That means down here, I got 5. Over here, I got 6. how would I find now the length of AC? Oh, and then I need to give you a number here. We'll say that's 10. How would I find the length of AC if this point here is 10, 6? What's the length? Yeah, you just subtract. The same thing we just did. You just subtract. We would say, well, if I want to know how long this line is, I would say 10, because this value here is 10. This value is 5. I'd just say 10 subtract 5, and it gives me a length of 5. The same thing we did in the other one, is just we're not subtracting 0. We got to subtract a different number. 10 subtract 5 tells me that is 5 units long. I do the same thing with the y's. If we'll say that's 10, I would say, well, 10 subtract 6 tells me that is 4. Something like that. That's all you're seeing when you see this really weird second version of the equation. Here, this is a better. When they show you this x subtract h thing and y subtract k thing, they're just finding the length by saying, I need to subtract this x, and they call that h instead of another x. But it's almost like we're doing the y2 subtract y1 thing, x2 subtract x1. You're really just subtracting 2 x values and 2 y values. Why they did h and k, I'm not really sure. I guess they wanted this to be the center of the circle. So those 2 points together make the center of the circle. So just understand, when you see a circle and a squared, b squared, c squared, all that is it's just the equation to find every point on the circle. Every point on the circle will fit that equation. The center of the circle is based on this second value. God, just corrected this like 8 times today. I'm crazy. So the second part, whatever we're subtracting from the other value, that's the center. They may tell you HK, they may have numbers there. I don't know how it's going to look. Just understand those 2 things. Let's try to see this. Whoop, nope. I don't know what my board has been doing this a lot lately. Those actually highlighter work better. Those 2 values are the center of the circle. The one that's with the x is the x value for the center. The one that's with the y is the y value for the center. So h comma k is the center of the circle. So up here, the center would have been 5. What was it? 5 comma 6 would have been the center of that circle. And that's what you would subtract from the other x value to put into the equation and solve for the whatever the radius is. That's all I'm going to do with it. I'm going to show. I guess I'll show this really quickly for people. I mean, I'll probably record tomorrow also. So very quickly, just I'm going to go over some stuff for the kind of the rest of what we're doing this year, really. So this is your calendar. It's my calendar, actually. So stuff that you see repeated over and over and over again. That's just reminders to myself. That's how I help myself remember stuff. I'm trying to learn different things. But for your standpoint, this 29th is a big day. You got your deadline for the retake. So it's the retake that's written up there. And you have the quiz on the stuff we're doing this week, which I don't think is going to be too bad a quiz. I think it's going to be certainly relative to what we did in circles. It won't be too bad. So a lot of you could use a good quiz grade. So make sure you're ready for that. And if you're going to do the last circles, or not the last circles retake, but that circles retake, you got to, and you need a tutor. Some of you'll need a tutor to do the circles retake. Then that'll be a deadline there. The 3rd will be the deadline. I haven't written it up yet, but for the one that I just put into focus. So those grades I just put in Sunday night or whenever I put them in, that deadline is going to be the 3rd. I'll write that up next period during my planning. It was tangents. Yeah, inscribed angles and tangents. So the third will be inscribed angles and tangents. And then everything is done. Well, every quiz, I should say. We probably won't have a quiz on the 6th because you wouldn't have time to do any retakes really by the time I graded it. So we're gonna just do exit tickets that week where it says exit tickets. I'm not gonna do any big quizzes. You might have an exit ticket every single day. Your exit tickets might be worth more points. So instead of a 1-point exit ticket, there might be a couple questions and it might give you 2 points for them. We're just not gonna do any big quizzes after the 29th. And then the 10th is the last day for any retakes, makeups, and that's your last day to do any of that. Don't wait until the 10th to do stuff. Like all the time, you wait, and something happens, they don't show up to school on that day, and they don't get to retake. You've got plenty of time to do retakes. Currently have almost 2 weeks. Means between, even if you're absent, between 7 and 10 days, depending on with that particular situation. Don't wait until that last day and come to me and say, oh, I couldn't do it because I couldn't make it to school. I won't care. I mean, I do care, but I want you to understand accountability. That's my number one priority over even geometry is understanding accountability. And deadlines are dead. Unless you're in the hospital for like a week or something like that and you have, that excuse with the school. So again, make sure you take the exit tickets seriously. That's the last thing I'll say. A lot of you aren't taking advantage of the exit tickets. Treat them like a quiz. Might even be more important to treat them like a quiz because they're the ones that are pretty easy that you can get 100s on if you take them seriously. If you just think that you learned enough in class to get away with doing it, you're missing the boat, not taking advantage of it. So make sure you treat them like a quiz. Do the practice problems. I always tell you what they're on. Oh, I didn't tell them when it was on today. Oh, again tomorrow. They may just have to learn it tomorrow. So you may have to learn it Thursday too. We didn't get through much. Any questions on any of that stuff then? Like what you need to know for. Yeah, we didn't really get through enough new material for me to even tell you what it's going to be on. Not at least. All right, so you're not going to tear out pages today. Just take some notes. So get out your own paper. If you need paper, I have some up here. Raise your hand if you need paper. Anybody else that wants paper? Adam's not gonna go. Anybody else has it? You have paper? All right. So you get these first few formulas on the reference sheet. I'm not going to pass out reference sheets. Just trust me, they're on there. Really quickly though, really quickly, I want to tell you kind of where we're going to, like what the conceptual part is. A lot of this is going to just be formula, but there will be some conceptual stuff that comes in. And the conceptual stuff is just understanding that we can take virtually any. Yes, yeah, you still call it a polygon, even if it's super weird. We can take any polygon, typically, certainly in a math class, and we can break it in, even if there's no specific formula for that weird shaped polygon, we can break it into shapes that we know. I'll just do a simple one, and I'll ask who knows what I'm drawing. Anybody know what that is? Could be a salt shaker. Dylan, what's that look like? Why not? I'm calling on you for a reason. Because you should be familiar with that shape.
Oh, that's the eight.
That's a basketball shape. So free throw line right there. Basketball goal would be back there. And then there's like a semicircle out there. So we don't have a formula to find the area of the free throw / paint. What do you call it when you play like that? But what do I really have there? I have half a circle. Well, it's technically a rectangle. I didn't do a very good job of it. I didn't do a very good job of drawing it. I have a rectangle that I can figure out the area of, and I can figure out the area of a circle and then cut it in half. And now I figured out the area of the paint. So that's kind of where we're going, is recognizing that when we get a weird looking shape, we can break it down into smaller shapes that we know, sort of like they're making a parallelogram, breaking it into a triangle. And then you could break it over here into another triangle. It's the exact same triangle, actually. And now you have two triangles in a rectangle. Now, there happens to be a formula for a parallelogram, so we're not really super worried about breaking this down, but you can do it. If you really, really were intuitive and you understood that concept, and you forget, well, you don't have to really memorize formulas, so there's no sense in doing this, but if for some reason you ever didn't have the formula, then you could say, well, I know that it's just two triangles. It's actually the same triangle. I can figure out the area of that triangle. I multiply it by 2. Then I just need to figure out the area of this rectangle inside and add that onto the two triangles. That's the concept that we're going to get to really in the next lesson. I think everything in this lesson has a formula. So that's what I just said. So that part, when you tear pages out tomorrow, the area of a polygon is just the sum of all of the areas if you break it down into smaller shapes, which makes sense, and I think we all understand that. Again, you have a formula for a parallelogram on your sheet, but so here's where you need to tune back in. There we go. They do not give you everything you need. It's not like you can just look at the formula and go, oh yeah, well, there's that number, boom, done. You're going to have to calculate out one of the pieces. So here's the formula in this. The area of a parallelogram, and it's actually the area of a lot of shapes. What other shape is that the formula for? Based on height. Not a triangle, because that would be 1/2 based on height, but close. Say it again. Not circle, because that would involve pi. Anytime you have a circle, you're going to have pi. Well, rectangle. A square is a rectangle, so you can still say it, but really it's for a rectangle. This is the formula for a rectangle. It's just that with a rectangle, we have the two numbers we need. We remember probably from middle school length times width, but length times width is the same thing as base times height. If that's 8 and that's 4, I just say, again, I'm going to use base times height since that's what we're on. The base times the height means the area, that is 32. But here's the thing with a rectangle. I have the height. The height is a perpendicular line to the base. Well, in a rectangle, I have perpendicular line. So I'm good to go. I don't need to do anything. I don't have perpendicular lines in a parallelogram. I have to create them. So I have to create a perpendicular line, which is what they're doing here. That line right there, they're creating a perpendicular line to the base. And I have to solve for the length of that line. I have to come up with the height. So that value right there is the height. They don't give that. I mean, it's maybe, I doubt they're going to give you the height on the EFC, but maybe they give you a super easy problem and they already draw the height in. I doubt that happens. So just understand, you can't just rely on the formula sheet and just plug numbers into formulas. You're going to have to solve for pieces of that formula just like when we did those formulas before, there were pieces you had to solve for. Like they didn't have all the information you needed. You had to solve for some stuff when we did surface area and volume a long time ago. It's going to be the same thing in these next few lessons. So with that in mind, how in the world do I solve for that line right there? Actually, let's do this. How do I solve for that? What should jump out at you that we have seen a lot of in the last couple of weeks? Well, how'd you know that? What do you see that tells you that? Besides reading it in the text up there. Say louder. That should always jump out at you. They give that to you for a reason. You will have to draw that in. They're not going to just draw the shape out for you. They're just going to give you a parallelogram. Actually, they did draw it in here, but I would not expect the EOC to be that easy. I would expect them to just give you a parallelogram with nothing drawn in. Okay, let's get rid of this. So I would expect them to do this. Give you two numbers. Well, actually, they'd have to give you three numbers. 10 and 12. And you have to understand, oh boy, they would have to draw it in. So how would they? Somehow they have to give you this little piece. So maybe they will have to draw it in, or maybe they will draw it in for you. But you can't figure out that little piece down there on your own unless they give you something. Odds are they might actually draw it in just because of that. So that's why if you'll notice, they're always giving you that little piece. We can't figure out, unless you had to do trig, which theoretically could happen. You could figure it out if you only had one side and if you knew the measure of an angle. So that's when we did the cosine, sine, tangent stuff. So anyway, you probably will get it, would be my guess. We'll see when we get the practice problems. Thursday. But once you know that, you do a squared, b squared, c squared, solve for the height value, assuming that's what you don't know. It could be that you don't know something else, but most likely I would think it would be height. I think this one, they said in the last class came out to be like 24. So once you know that's 24, now you just multiply the base. So this is the base. We don't use the 7. We just take the base of the figure and we multiply it times the height, which we just solved out to be 24. And that'll give you the area. Again, just because the formula looks super, super simple doesn't mean there's not some stuff you're going to have to solve for in order to get the final answer. But still, I don't think it's going to be nearly as bad as some of the circle stuff we did. So make sure you're ready. And you're only going to have 2 lessons on it. One of them short. Today's pretty short lesson. So there really will only be about 3 or 4 questions. I might give you an exit ticket on it as well, since it'll be a short quiz. Either an old exit ticket that you can take and try to improve on, or possibly a new one. It won't be anything new to put on there because we're doing an exit ticket on Thursday. All right, so trapezoid, kind of same concept. I'm not going to spend forever on it. Trapezoid has its own formula. It's actually the same exact formula. Formula. I guess formula's on the. Oh wait, there we go. Right here. Oh, it's not the same exact formula. I'm sorry. It's same concept. We're just breaking it into smaller shapes. So we're breaking it into rectangles and triangles. Sometimes, though, a trapezoid is a weird shape. It's not symmetrical. So we might have a trapezoid like that, where it's not quite, it should be parallel on the bottom. So we have a trapezoid like that. The formula for that is the 1/2. I just had it on the screen. Yeah, that one I circled. So it's 1/2 the height times base 1 plus base 2. I will tell you, in these, the math's going to be a little trickier probably. There's a very good chance sometimes they give you the height in this, but then they don't give you one of the bases. So you would have to fill out the base, but the formula never changes. You just got to plug the information in the correct spot. Just understand the height is still at a perpendicular direction. Right angle. That's the height. Always, always, always. That's how height. When we do a triangle, you got to find the height of a triangle. Same thing. We may have a weird triangle like this. So if that's the triangle, the height we would have to draw in, if they don't do it, that is the height. That side right there is the height. We have to draw a perpendicular line. So that's one note you should have from today. You don't need to write down any formulas. You need to write in height is a perpendicular line to the base, so 90 degrees. So height, perpendicular line to the base is the bottom, typically the way we're going to see the figures. And I would make a little note saying, I will probably need to solve for the height. I would guess most of the time you're going to have to, they're not going to give you that unless they want you to solve for a base or something like that. Again, we'll see what the problems are like when we get to it on Thursday. So. I guess we could do one. Why don't we do one really quickly? I don't want to do the check problem. Here, let me zoom out. So you'll have to draw this since you don't have your book pages today. Oh, we did that actually, yeah. So we do need to do the check problem. All right, so here's your problem. Do this check problem, draw the picture really quickly. For Calvin, he probably has his pages done, 266. The very top, the check problem. So it's multiple choice, so you'll know. So draw that out really quickly. It doesn't have to be perfect. It is a parallelogram. So we're going to talk and review next class a little bit about parallelogram. A lot of you made a mistake on one of the quizzes that would have been correct for parallelogram, but wasn't correct for the typical. Tutoring Thursday, if I didn't mention that, 2 to 3. Oh, there's 2 review videos posted on Circles already. So if you're going to do the 29th or even the one that's the following on the 3rd, I've already posted, actually, the video I posted might even be for the one that's the 10th. There's two review videos in Circle. So if you're planning on doing retakes, those. That's. I'm going to write it in self-custody. I'll give you a minute and then we'll go over it, and then that'll be the last thing we do. Not a lot of people doing anything. Let's go. It's probably going to be something like that. It's going to be your exit ticket. So make sure you got it. You're going to do nothing and you don't take advantage of it. It's about the easiest exit ticket you'll have left. After formula, there's one thing you got to do. It's probably good. Not, we don't have to do it. Then I'll do it. Probably do it. Where'd you get the 15? What you did? And that did. I just saw it 2 numbers. I thought you just used 2 numbers in there. But you did that first. All right, so we'll do it really quickly. Again, formula is going to be something you'll have. You don't need to memorize it. It's just the base time, the area is the base times the height. We just have to figure out the height. We do not know the height. The height is the perpendicular line to the base, but we do know two of the three values of a right triangle. So which one's the important one out of those? And then this one's the one we're solving for, the height. Which one's important? The hypotenuse is one you have to understand is side C. So 17 is side C. These don't really matter. We could do h squared first or second. 8 squared equals 17 squared. If you do the math on that, I'm doing a quick version. If you don't get this, we can talk about it next class. If you solve it all the way out, h is 15. So again, 17 squared, subtract 8 squared, subtract 64, and then take the square root. Don't forget that. So h is 15. Well, I just take the height times the base, so that would be the base. I don't know what this section is down here, so I have to kind of go up there. So if you do 15 times 21, get that. So you should have gotten that. Really quickly, we could have also done this triangle if it's a parallelogram, which they tell you this is. That triangle actually fits right here and makes it a rectangle. So this rectangle is the same area as the parallelogram, because that triangle, if we cut it off and flipped it over to there, would fit in perfectly and form a rectangle. That's why they have the same formula, because they're really parallelogram, really just a rectangle. Just it's just kind of same. But we would still need to solve for the height, so it doesn't really change anything. But 15 times 21 for the rectangle would be the same formula. And we could have figured out the area of both triangles and added them to the little rectangle in the middle. If we would have cut this triangle off here, we could figure out this area, x plus y, and then plus all of that, which would have been what? 13 times 15 in the middle, because we see the 8. There's a bunch of different ways to do it. Just the more you understand it, the better off you'll be when we start getting to the weird things. I guess I thought in this chapter, the next chapter, I guess. Oh, we do have to use trigonometry. Son of a gun. Yeah, they do want us to use angles and stuff to figure out measures. That's gonna get tricky. So for Philip. But again, you get that on the bottom record sheet. So we'll wrap this up on Thursday, and your exit ticket will be something like one of those where you do probably a parallelogram. What we did today. I don't know. We'll see. I feel like that's too easy. So it depends on the harder you work on Thursday, the easier the exit ticket will be. But I might just create it on the fly and just say, here's problem. Now, like change the numbers for different people. Whoa, what was that? Oh. We got an active thread drill that we're getting a port. I think we're just talking about it. Oh, one more thing. Make sure you get if you do go to tutoring and work with somebody, make sure you get something filled out. I haven't been giving out slips. Have to have them sign off on the fact that you entered it. So they know that, but they don't always remember it. So it's up to you to have them do that. If you show up here and you don't have anything, I'm not going to take a quiz. You got to, well, it's creating more work for myself. You're not gonna. Right? Well, I didn't do attendance. Did I do attendance? I don't remember. I don't remember if I did or not. Oh, yeah, let's stop that. Not that it matters. I mean, it's just, they post your names all over the place. But the shorter the video, the better.